This video is still on the chapter of vectors in vector spaces, and this video is still on the chapter of orthogonality. I finished the previous video checking that these three particular vectors, vector u1, 1 minus 2, 3, u2, 1, 2, 1, and u3, minus 8, 2, 4, these three particular vectors, they are orthogonal. Okay, so in this video we are going to pick a vector. Let us say vector w, where w is 13, minus 4 and 7. And now we are going to be asked to write this particular vector w as a linear combination of these three vectors. So we are going to write w as a linear combination of u1, u2, and u3. Okay, what does that mean, to write w as a linear combination of these three vectors? And you see, these three vectors, they are all orthogonal. That means that we have to find, for vector w, we have to find a value x times u1 plus y times u2 plus z times u3, right? So we have to write w as a linear combination, meaning we put vector u1, u2, u3 here, and we have to find scalars x, y, and z so that we get vector w. Okay, so I'm going to write here vector w, 13 minus 4, 7. I'm going to write it as a column, okay? And I'm going to write x times 1 minus 2, 3. So this is vector u1, okay? Plus y, u2 plus z, u3. X times vector u1, y times vector u2, and z times vector u3. Okay, this is easy now, but at the end of the day this is nothing else but scalar multiplication, right? And adding matrices. Okay, so we have 13 equals x times 1x, y times 1y, minus 8z, x times minus 2, so minus 2x plus 2y plus 2z, 3x plus y plus 4z. So we have nothing else but a system, right? Probably you're more used to this sort of display, right? X plus y minus 8z equals 13, minus 2x, etc. Okay, and now you simply solve the system, and the system will be solved. I got x equals 3, y equals 2, and z equals minus 1. Okay, so these are my solutions. Okay, so if I replace this value of x, y, and z, if I replace these values here, right, if I replace those values here, here, and here, I can write w as a linear combination of these three vectors. Okay, you can try now. If you put 3 here, right, just pick the values from here, y equals 2, if your y is 2, and if your z is -1. Okay, so 3 times 1, this is 3, for instance, just the first line. 3 times 1, that's 3, plus 2, that's 5, minus 1 times minus 8, that's 8, 8 plus 5, you get 13, right? And that is correct. Okay, so this is the solution for the system. X equals 3, y equals 2, z equals -1. I'm showing here a second solution. In this second solution, I'm going to use a very important regularity. So if W1, W2, and W3, if they are three orthogonal vectors, and if a vector W can be written as a linear combination of u1, u2, and u3, for that you have to find scalars x, y, and z. So if this is true, that implies, I'm not going to prove this, that x will be equal to your vector w inner product with u1, so this scalar here will be equal to the inner product of w, so this one with this one, inner product with u1 dividing the absolute value squared. Okay, let us see if this works for our previous example. Okay, we are going to take this and we are going to try. What we did here, we had vector u1, u2, and u3 and w, and we wanted to write w as a linear combination of u1, u2, u3, and we had to solve all this huge system. Okay, let us see if our system now is quicker. So we need w, right? We need this vector, and we need u1. So in our case, w was 13 minus 4, 7. Inner product with u1. u1 is 1 minus 2, 3. Dividing the absolute value of u1, so that will be 1 squared plus minus 2 squared plus 3 squared. But the absolute value here is squared. Okay, so squared. And if we do this calculation, we will get the value of x, and this is much quicker than solving an entire system. So I'm getting 13 times 1, 13, minus 4 times minus 2, 8, 7 times 3, 21. Here this will be 1, 4, that's 5, plus 9, that's 14. The square is going to cancel with the square root. So I am getting, if I'm not wrong, 42 dividing 14, right? And that is 3. So x equals 3. Okay, much quicker, right? So please do that to the value of y, and do that to the value of z. This is a much quicker algorithm. And check if you get the previous value. If you get 3 for x, 2 for y, and -1 for z.